that it is negligible. That means you can neglect, you can ignore, you can take it as 0. So we are ignoring this because this is the product of two small quantities. Delta m is small, delta v is also small. So then finally we are left with this m delta v, and if I take minus delta m common, I have v plus u. Now try to understand, of course delta v is very small. The velocity of exhaust gases relative to rocket. The velocity of exhaust gases relative to rocket, if I have to write velocity of exhaust gases relative to rocket is minus u minus v, because I am ignoring delta v. Delta v is small. So v plus delta v is v only. For example, 1 crore 1. 1 crore plus 1 can be taken as 1. You can ignore 1 because 1 crore itself is very big. So direction wise, u is negative, so minus u minus v is positive. So basically this is u plus v minus of u plus v is, so this I am denoting it as v rel, relative velocity of exhaust gases with respect to rocket. So now I can write plus, okay, plus v rel into delta m. With proper direction I am taking with proper direction. Is it clear? Minus v plus u is what? V rel. So now rate of change of momentum. It happened in delta t time. So rate of change of momentum is change in momentum in 1 second. Change in momentum is in 1 second. Is rate of change of momentum. Rate of change of momentum is change in momentum per unit time interval in 1 second. So you have m delta v by delta t plus delta m by delta t into v rel. But this is the net force acting. Yes or no? Be careful, you have to be very careful with this, because this is minus. Magnitude wise if you take, you have to put a minus. And that vectorially if you take, it's okay. I'll put this vector sign. So what will be the net force acting?